Open your book to page 203. This is lesson 6.9, and this lesson is on the square roots of the signed number. So if you look at example 1, it says the number 9 has 2 square roots. So in other words, square root of 9 equal to positive 3 and negative 3. But we're only going to use the positive. Okay, so when you take the square root of a number, we're just going to focus on the positive. This is called a principal root. So we're going to focus on positive. So let's go to example 2. A. So you got square root of 16. Now square root of 16, this is equal to 4 because 4 times 4 equal to 16, right? Because this is equal to 4 times 4. And these are called radicands. Okay? So each of these is a radicand. So 2 radicands make an integer. That's what square root means. Okay? Square root means you need to get 2 of the same number to make an integer. Okay? So you have to think about what times itself, what times the same number will give you that 16. So the answer is 4, right? So 4 times 4 gives you 16. Therefore, the answer is 4. Okay, so 2b, square root of 36, the answer equal to 6. Because 6 times 6 will give you 36, right? Again, you don't want to write this part out, but I'm just writing it out so it helps you visualize. So 36 equal to 6 times 6, right? So again, 2 radicands make 1 integer. Okay, let's go to 2c, square root of 1, this is equal to 1. Right? Because 1 times 1 equal to 1, right? Okay, example 2d, square root of 0, this is equal to 0. Because 0 times 0 equal to 0. Now you go to 2e, you got square root of 4 over 9. Now when you have fraction, you just do each part individually. So square root of 4 is 2, square root of 9 is 3. And so answer is 2 over 3. So again, you just do each part individually. So it's not that difficult. Okay, you go to 2f, you got negative square root of 4. So what you need to do is you need to go down and account for each part. So negative is equal to negative, right? You just don't do anything with that, right? This part of here, square root of 4 equal to 2. And so your answer would be square root of, the answer would be just negative 2. Okay? Okay, now just a note, okay? On the bottom, when you have a square root, on the very bottom of page 203, when you have square root of negative 4, okay, so this one you cannot do it yet. So this is called non-real. Okay, non-real number or non-real, because there's no real number that you can multiply to get that, right? Because if you have like a 2 times 2, you get 4, right? You will never get negative 4. And if you have negative 2 times negative 2, right? Again, you get positive 4. So there's no number that you times it by itself will give you the negative 4. Okay? Now, when you get to algebra 2, you're going to learn something called the imaginary number, which you will get to when you get to algebra 2. But right now, when you have a negative inside the square root, then just write down non-real number. Okay, it's not real. Okay, let's go to page 204. Page 204, you learn another term. It's called a rational number. The word rational came from the word ratio. See over here? And you learned about earlier, right? Ratio is a fraction, right? So anything that can change into a fraction is a rational number or fraction. So some of the examples. So if you look at some of the examples, like this one over here, right? So again, remember, rational number is a ratio, is a fraction, right? So this is a fraction, so therefore it's a rational. Negative 3, you can convert into negative 3 over 1, so it's a fraction. So anytime when you can change into a fraction, then it's a rational number. Okay? So 2 and 1/2, it becomes 5 over 2. So again, it's a rational number. So all fractions are rational number, all the integers are rational numbers, all the mixed numbers are rational numbers. And all the decimal terminating means that's not go on forever. Okay, so all the decimal that is stopped, that does not go on forever, are fractions or rational. The next one is all the repeating decimals are rational numbers, because all the repeating decimal you can convert into fraction, which we will learn later on. Okay, and when you have a square root, right, that can change into an integer, then in this case, if the inside is a perfect square, then it's a rational, because again, whenever you can simplify into a fraction, then it's a rational number. Okay. And on the next one, the next term you have to learn is irrational number. Notice IR in the front. The letters IR in the front means not. So irrational means not rational, means not fraction. So anything you cannot change into a fraction, then it's not. It's not rational. So it's irrational. So like over here, square root of 2. So square root of 2 is 1.4142. It goes on forever and does not repeat. So if it goes on forever and does not repeat, then it's irrational. Like square root of 3, right? Again, it does not stop and does not repeat, so it's irrational. Like the simple pi is 3.14159. Again, it goes on forever and it doesn't repeat. If it's repeat, then it's rational. But if it doesn't repeat and it doesn't stop, then it's irrational. Like this one over here, right? Again, so if you notice, most of them are square roots.